Geometry 8-4, trigonometry. All right, finally, we're doing something with these triangles, all this triangle stuff we've been talking about. Now, we're going to start using this information, all these ratios and other triangle knowledge that we have now to use trigonometry. So, trigonometric ratios, and we're also going to write here. You'll see why in a moment. Okay, so trigonometric ratios are ratios having to do with a triangle. So we're going to draw a triangle here. And these trigonometric ratios can help us to find the values of the different parts of the triangle using our calculators or some other knowledge that we might have. And so here's the first one we're going to look at. The first one is sine. And sine is written like this. Sine of A equals, okay, so let's label this triangle real quick. The top is A, to the right is B, and C is right here with the 90-degree angle. The side across from angle B is side B, across from C is side C, and across from A is side A. Notice the angles, the points are uppercase letters and the sides are lowercase letters. Okay, sine of A is opposite over hypotenuse, which is also, or I'll say or. So if I'm looking at A, the opposite over hypotenuse. So the opposite side over the hypotenuse. Remember, the hypotenuse is the one across from the 90-degree angle. So opposite side over hypotenuse. So A over C. Sine of B is opposite over hypotenuse. Still, sine is always opposite over hypotenuse. And so the sine of B is opposite, which is B over hypotenuse, which is C. B over C. Okay, so sine is one trigonometric ratio. Here's another one, cosine. Now, sine was opposite, sine, opposite over hypotenuse. Cosine is cosine, adjacent over hypotenuse. Okay, so let's look at that one. So if I want the cosine of A, that's adjacent over hypotenuse. So I find cosine of A, so A is the angle that I'm looking at. Cosine is the adjacent, that's the one that's next to it, over the hypotenuse. So hypotenuse is here, and the adjacent leg is what's going to go in the numerator. So adjacent, which is B, over hypotenuse, which is C. Cosine of B, so angle B, cosine of angle B, again, adjacent over hypotenuse, adjacent over hypotenuse, or the adjacent, the side that's adjacent to B is side A, and the hypotenuse is C, so A over C. Now there's one more trigonometric function that we're going to learn, or ratio, which is tangent. Tangent. And tangent, we use TOA. So tangent of A is opposite over adjacent. Opposite over adjacent. Or, so let's see, where are we? Tangent of A. So A, opposite, which is A, over adjacent, which is B. A over B. Tangent of B, of angle B, again, is still opposite over adjacent. Or, so we go to angle B, and we say opposite over adjacent. Opposite is B, adjacent is A. So B over A. Okay, so you're going to use this. Don't lose this. You're going to use this. Don't lose this. All right. So let's write SOHCAHTOA again. So notice how many times I'm writing SOHCAHTOA over and over again, all over the place. Maybe that's important. So S is sine, O is opposite, H is hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Okay, so we're looking at this stuff now. Let's see if we can do this with some numbers instead of just letters and see if this can come together a little bit. So I have a right triangle. This only works with right triangles for now. So this is triangle PRQ, and RQ is 15, QP is 17, and RP is 8. Okay, now I want to know what is sine of P, cosine of P, and tangent of P. All right, so we're going to do this together here. Sine of P. So first, I want to pay attention here to see what is my hypotenuse. That's important, to be able to find my hypotenuse. Remember, the hypotenuse is the side that is across from the 90-degree angle. So 17, that one's my hypotenuse. Okay, so that's going to help me so I know which one is my hypotenuse. Sine of P. Okay, here I go to P. Sine of P, I go look at P. Sine, remember, is opposite over hypotenuse. So, opposite over hypotenuse. So here's P. Opposite is 15. That's the side that's opposite the angle. 15 over the hypotenuse, which is 17. So 15 over 17. And that's it. Cosine of P. So I'm going to go here for P again. Now cosine is adjacent over hypotenuse. So adjacent is 8. That's the one that's touching the P over hypotenuse. So 8 over 17. And then the tangent of P, so I'm here at P again. The tangent is opposite over adjacent. Opposite is 15, adjacent is 8. So opposite, 15, over adjacent, which is 8. Okay, so now you're going to do the same thing, but you're going to find the sine of Q, the cosine of Q, and the tangent of Q. All right, so we're using the same triangle. Go ahead and go. See how you do. All right, welcome back. Let's see how you did. So I'm going to find Q. My hypotenuse is still 17. That doesn't change. But now I'm looking from this angle. So the sine of Q, sine at this angle, is opposite over hypotenuse. So my opposite from Q is 8 over hypotenuse, which is 17. 8 over 17. Cosine of Q is adjacent over hypotenuse. So the leg that is touching Q here is 15 over the hypotenuse, which is 17. That'll give me the cosine, 15 over 17. Now the tangent of Q. Tangent, remember, is opposite over adjacent. TOA, opposite over adjacent, 8 over 15. All right, and that is the U try. Let's keep moving. Special right triangles. Special right triangles. So here's an example. Tangent of 30 degrees equals. So now let's figure out what tangent of 30 degrees equals. Okay, so let's go ahead and draw a triangle here. So remember, we're talking about right triangles. And then I'm going to say 30 degrees is one of these angles because I'm looking for tangent of 30 degrees. So I say 30 degrees. So here's where I'm coming from. Now, if this is 30 degrees and this is 90, this one's got to be 60. Okay. So let's just say that this smaller side is x. So remember, if this is x, then the hypotenuse has to be 2x. Remember, 2 times the smaller side, or the smaller leg, is will give me the hypotenuse. And then the longer leg is the side times the square root of 3. So that's my special triangle that we just learned about last time we took notes. And so now tangent of 30 degrees, I'm going to look at 30 degrees. And remember, tangent is TOA. So I'm going to go opposite over adjacent. So it's going to be x over the adjacent, which is x square root of 3. Remember now, I've got to multiply. I can't have this radical down here, so I need to multiply by square root of 3 over square root of 3. And when I do that, I get square root of 3 squared, or multiplied by itself, is the square root of 9, which is just 3. So I get 3x for the denominator, and then x times the square root of 3 as the numerator. Now I've got x over x. X divided by x is 1, so that just goes away, and I have the square root of 3 over 3. So the tangent of 30 degrees is square root of 3 over 3 all the time. Every time you see tangent of 30 degrees, square root of 3 over 3. Now, I can do this same example here for cosine of 45 degrees, but I'm just going to tell you what it is. Cosine of 45 degrees is the square root of 2 over 2. Okay, you're welcome. All right, so there are a bunch of these things. There's tangent of 60 degrees, cosine of 30 degrees, cosine of 60 degrees. You can see that in your book. We can work on it. We will be looking at this in much more detail in the coming chapter. Okay, what we're going to do now is we're going to find x, or find the value of x, to the nearest hundredth. And so for this one, you're going to want to, I think, let's see, you're going to want your calculator. So here's a calculator that has sine and cosine and tangent on it. Here is a triangle. It's a 90-degree triangle. It's a right triangle. This longer leg here is 18. This shorter leg is x. And this is 25 degrees here. Now, notice this is not a special triangle. It's not a 30, 60, 90 or a 45, 45, 90. This is just a regular triangle. Now, I want to know what is x. Okay, so we're looking at this. I don't know how to find x, right? I can't do the Pythagorean theorem because I don't know what the hypotenuse is. Remember, this is the hypotenuse over here. So I could, if I knew this, if I knew what the hypotenuse was, then I could use the Pythagorean theorem, but I don't know what the hypotenuse is. What I do have, so if I'm looking at 25 degrees here, I do have this adjacent side, and I have this opposite side. So I have adjacent and opposite. So now I got to think, which trigonometric function uses opposite and adjacent? It's tangent. So what I do here is I say tangent of 25 degrees equals opposite over adjacent. Opposite is x, adjacent is 18. So TOA, remember, opposite over adjacent. So now I can solve for x. And the way that I do that is I need to get this x by itself. So I'm going to multiply both sides by 18. And so now I have 18 times the tangent of 25 equals x. Now, all I need to do is get my calculator, and I say the tangent, so I find tangent here, tangent of 25, and I could just do that there and say equals, and then I can say times 18. I can put it in a calculator a little bit different way, but that way might make it a little bit easier. And so now I want the nearest hundredth, so I'm going to say x is approximately 8 so I got 8.3935. So I'm just going to round this 3 down, and so I have 8.39. I have rounded to my nearest hundredth. Now, if you have an iPhone and you go to the calculator, you don't see sine and cosine there. But if you go like this, maybe I have to sign in first. If I go to my calculator now, and I go sideways, then I have a whole bunch of, I've got my trig functions down here. So I can clear, I don't know what I was doing here, but I think that you have to push 25 and then tangent, yep, in order to get that. So you do the number and then you apply the tangent and then you say times 18, and that should get you 8.39 there. So if you have an iPhone with or another phone with this kind of calculator, you got to plug it in a little bit differently than you do with one of these Texas Instruments ones. But there you have it. That's how we do it. Let's do another one. Here is a right triangle. And this here is 70 degrees. That angle is 70 degrees. This shorter leg is 15, and the hypotenuse is x. All right, so now I have to think, here I am, I have to gotta put myself in this corner, and I need to think about what information do I have. I have the hypotenuse, and I have this side that's right next to my angle, so that's the adjacent side. I don't have the opposite side. So I have the adjacent side and the hypotenuse. So I have to think what trigonometric function or ratio uses adjacent and hypotenuse. So I might look at my notes back here, and I see opposite and hypotenuse, opposite, adjacent, adjacent, hypotenuse. That's what I need. I need the one that starts with C, that's cosine. So I'm going to say cosine of 70 degrees equals adjacent, which is 15, over the hypotenuse, which is x. Now this gets a little bit messy. I can't multiply both sides by 15 to get that x by itself. That I would just end up with, the x would still be in the denominator. So what I need to do is multiply both sides by x, and so those x's go away. And so now I have x times cosine of 70 degrees equals 15. And now I just need to divide both sides by the cosine of 70. And so now I have x, so those go away. X equals 15 over the cosine of 70 degrees. Now notice here, this and this are similar. All I did was what I just did was I swapped x and cosine of 70 here. I used algebra to do it. So that's what I did. I just swapped x and cosine of 70. So if I put that into the calculator, on the Texas Instruments one, I would say 15 divided by cosine of 70. I just close my parentheses there, and I end up with 43.86. X is approximately 43.86. And let's do one more. Let's have you do this one without me. Here is another right triangle. And this is X, and this is 5, and this angle is 7 degrees. So figure out which trig function you need to use, or which trig ratio you need to use, and solve it just like we've done these other two. All right, go. All right, let's see how you did. So here's my angle. And I see that I don't have the adjacent side. I have the opposite side and the hypotenuse. So sine, or so, has the opposite and the hypotenuse. So I want to use sine here. So sine of 7 degrees equals the opposite, which is x, over the hypotenuse, which is 5. And so for this one, I just multiply both sides by 5. And then I can put this into my calculator. I'll know what x is because those 5's go away. So I just say sine of 7 degrees equals 0.21 blah, 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 blah. I need to multiply it by this 5 here that I had to do for both sides to get x by itself. And so x is approximately 0.61 or 0.61. It was, so that was the hundredths, rounding to the hundredths. Okay. Good. Now we're going to keep going. We got some more stuff to do with these trig ratios. We're going to, you try another one. Oh, you try another one. Okay, great. So here's another triangle. And here's x, this is 34 degrees, and this is 28. I want to know what this, I want to know what x equals. So go ahead and try this out on your own. Okay, let's see how you did. All right, so I'm looking at this angle. I have the adjacent side, and I have the hypotenuse. I don't have the opposite side. So adjacent and hypotenuse, that's cosine, adjacent and hypotenuse, cosine. So I say cosine of 34 degrees equals adjacent over hypotenuse, x over 28. Multiply both sides by 28. I get 28 times cosine of 34 degrees equals x. And so x is going to be approximately, if I plug that into my calculator, it's approximately 23.21. All right, now we're going to do a bit more notes and we'll be done with this section 8-4. Inverse trig ratios. Now inverse trig ratios are cool because they look like this. If sine of A equals x, then sine of the inverse sine of x equals the measure of angle A. So what we're doing here is we're saying we put the ratio in here and we get the angle out. So before we're putting the angle in and getting the ratio out. Now we're putting the ratio in and getting the angle out. So same with this one, cosine of A equals x, then, oh, I didn't put then, I should put then here. Then cosine, inverse cosine of x equals measure of angle A. And tangent of A equals x, then inverse tangent of x equals measure of angle A. So now we're going to do something called solving triangles. So we're going to solve triangles. And what this means is that we are going to find the measures of all sides and angles of triangles. All right, so here we're going to have two triangles to do. We're going to do an example, and then we're going to do a U-try. So here is the first triangle we're going to do together. This is triangle ABC. BC is 18, AB is 27, and angle A is 42 degrees. Okay, so now let's write down everything we need to know. We need to know measure of angle A, measure of angle B, and measure of angle C. So that's all of the angles. And then we need to know all of the sides. So the sides, we're going to say, well, we'll just say AB, AC, and BC. Okay. So we already know BC is 18. We know AB is 27. Angle A is 42 degrees. And angle C is 90 degrees. So we just need to find these two. That's it. No problem. Okay, measure of angle B. Now, we can find measure of angle B really easily by saying 42 plus 90. So we'd say 42 plus 90 is 132. And then if we subtract that from 180, then we get 48. Okay, now that's one way to get it super easy. But you're not always going to be able to you're not always going to have one of these angles. So we're going to use this inverse trig ratios to find this 48 degrees. So here's how we're going to do it. We're going to look at angle B because that's the one we want. We want to know angle B. And we have this adjacent side and the hypotenuse. So which trig function uses the adjacent and the hypotenuse? It's SOHCAHTOA, so it's cosine. So if I say inverse cosine of adjacent over hypotenuse, which is 18 over 27, that's going to get me measure of angle B. And so I can put this in my calculator here. So I say inverse cosine, so that's above cosine, so I have to push the second here. Inverse cosine of 18 divided by 24, 18 divided by 24, close my parentheses, equals, oops, did I put, oh, it's 18 over 27, oh goodness. Nobody even told me. Nobody corrected me. All right. Inverse cosine of 18 over 27. Goodness gracious. 18 divided by 27. All right. Now we got 48.18. I don't know why there's why we should have decimals there. I feel like I might have done something wrong. But anyway, 48 degrees is what we get there. 48 degrees. Now, AC, I want to find this side now. And the way I'm going to do it is the way that we've already been doing this. So I'm going to look at this angle, 42 degrees, and I've got this hypotenuse, but I don't have this side. So what I'm going to do, I've got, this is the adjacent side. So I'm going to say cosine of 42 degrees equals adjacent, which is AC, or I can call it X or whatever, over my hypotenuse, which is 27. So now I'm going to multiply both sides by 27, and then I put this into my